Welcome to ePathshala lecture series in computer science, and this is a course in cloud computing. In this module, we will continue with our discussion on networking, cloud related networking. So, let us look at what we have already seen in the last module. So, virtually everything that we do in the web application goes somewhere in today's world, it goes somewhere in some data center and a server is accessed. The data centers also need to communicate with each other for various administrative reasons. For example, Google has this is a statistics of 2011, where to ensure a continuous search, they had 12 locations. They have their servers in 12 different locations spread over 3 continents. Now, this is done to ensure various things, of which one is the security in terms of there should not be a downtime for any server, and the others are the usual of disaster recovery, planning for uptime, always high availability, etc. So, replicating the data and the communication and the computation, everything is a very common thing among large data centers. So, as soon as we replicate, we necessitate movement of data, communication among these replicated environment. Whatever we replicate, we immediately have a requirement that they communicate with each other, and this replication ensures that the availability is very high, which is always a promise for our cloud, and it ensures that there is a traffic load balancing, in the sense that if some locality has more requirement for a certain set of data, then to spread it out so that everybody does not go to one location. If we have that data spread across other geographical locations, it is better, and also we have latency reduction, because the users will be accessing the data from various parts of the world, and data being near them helps to access the data faster. So, to continue with this, the problem is the connectivity. Wherever we put our data centers, Google puts its data centers in 3 continents, 5 different continents, and thousands of servers, hundreds of data centers, but these data centers servers have to communicate with each other over the internet, and that is the major block of this work, because the performance of the cloud will be now dependent on how the internet performs. If the internet is very fast, then the cloud can, when we give a search in Google, it says we in 0.51 seconds these many result has been retrieved. It is dependent on the internet connectivity between the client giving the search and the servers from which the data centers from where the data came. So, therefore, there is a direct dependence. Unfortunately, internet is not meant for speed. The technology is 40 years old, and it is dependent on TCP/IP and cannot handle, it was not even designed to handle this kind of traffic. So, therefore, all these necessitated a better and improved method of networking among the data center servers, and this is what led to the development of virtualization in networking. So, in the last module, we looked at the first 3, and in this module we are going to look at the next 4 topics that are relevant to virtualization. So, the learning objectives of today's module is virtualizing the the higher 4 layers of the ISO-SI networking layer. So, we saw in the last module how our VLAN and our VPN, virtual private network, helped us to virtualize the physical components of a node and allowed VPN and VLAN to be implemented in a networked environment. These mechanisms affected or took the benefit of the first 3 layers of ISO-SI. Now, we are going to look at the virtualization of the higher upper layers, and as part of that we are going to discuss 2 specific mechanisms, which is one is called the NFV, which is the network functional virtualization, network function virtualization, and the next is SDN, which is the software defined network. And overall combination of these is called the network as a service, which is the NaaS, and we will look at the specific mechanisms that are tools that are required to implement SDN and NFV, and this is the objective of today's module. So, network function virtualization or NFV is creating a major excitement among the tele companies. So, what is the network virtualization? Network function virtualization, it is value addition to the higher layers of that. It is value addition to every layer of the networking environment, and it is additional values to the functionalities. So, that is what we are going to look at today. So, this decouples to be able to virtualize the network functions, decouples the physical network from the underlying equipments. So, the functionalities are dependent on the physical network, but the value addition to the functionalities can be done if we can virtualize the functionalities rather than being dependent on the physical network. So, the services on dedicated hardware devices are hosted in a virtualized environment, and the method for replacing the existing dedicated network appliances will define, create, manage, automate the functions of networking. Those are the network functions using software, and it will be a dynamically activated functionality that will be given. So, it will consolidate and deliver the components that will be needed. So, all the functionalities components will be consolidated and control it through software. So, it will be away from the physical environment, as we learned virtualization is all about, and allows the network operators to control the networking functions. Single control plane for management for all management and orchestration is what NFV. So, what is the advantage? Why we want to decouple the functionalities from the underlying network? The networking components are still required, and they are the components that are going to finally carry the packets. So, what is the point of decoupling that? Like every virtualization, network virtualization, like we saw server virtualization, we saw operating system virtualization. Similarly, networking virtualization also brings the benefit of doing things faster and cheaper. So, fast innovation, if anything needs to be tried out, any new technique needs to be tried out, doing it on the actual network is costly. In case it does not, the functionality does not work, and in case there is a correction that needs to be done on that functionality, then it may damage the physical networking components, or at least it will keep it occupied for such testing purpose. But in software it can be easily done. So, it will be given in a commodity hardware and run in a machine and implemented to see that it is doing the correct thing, and when we are convinced that it is doing the correct thing, then implement it, take the same logic to through the physical network. So, cost savings, how the cost is saved, because the functionalities are decoupled from the physical network. So, with the same physical network lot more functionalities can be implemented, and better manipulation can be done, thereby improving the cost, both the capital expenditure. If we can use the same network switches or network equipments for more traffic by manipulating it through a software, obviously the capital expense for implementing such costly equipments and the operating expenses of maintaining such costly equipments both will be less. So, the telecom companies today are very excited about doing some virtualization. NFV is one of them, and therefore, revenue improves, the performance improves, fault tolerance improves, it is more automated because physically we are not doing anything, and things are being done by virtualization and orchestration. And deployment is faster, new capabilities can be added much faster than actually procuring new equipments and implementing, installing these new equipments and doing it. So, to continue NFV, we still have the SLA driven, therefore, what are the promises we are making, and through software we can see whether the promises are available, it can be integrated and allocated. Quality of service therefore improves with respect to all the possible parameters of QoS. Visibility, automated monitoring, troubleshooting across physical and virtual network devices and functions are available, and how we are going to manipulate that is also easily done using virtualized environment. So, here is the overall architecture of NFV. We have NFVI, which is NFV Infrastructure, we have VNF, and we have one orchestration layer also. So, what is NFVI? This is the NFV Infrastructure. This will be a combination of hardware and software and the network equipments to have a complete setup where the virtualized network functions can be run, can be implemented. So, this is an abstraction of the compute storage network resources, or whatever storage or whatever resources are there in the operating environment, abstract it and create a NFV infrastructure in which the virtualized functions can be installed. So, services can be located across physical locations, anywhere they can implement and reside. So, allow operators to place their control at convenient locations. Now, the functions that are being virtualized, these are the virtual network functions. We can take any network function and we can run a corresponding software as a part of that. So, therefore, these are the network functions which are being virtualized and made available. We can for example, you can take the example of firewall. We can take the activity of firewall as part of our network function, and we can implement it in software and offer this as a service. So, therefore, this becomes a virtual network function offered as a service. Now, since this is done in software and is not dependent on the hardware, so the best part of doing this is we can split this any which way and we can combine them any which way. There is a lot of flexibility that is available in the implementation of this. Now, these functions are deployed in a virtual environment and they become the VNFs or virtual network functions. And this virtual environment is what we saw in the earlier layer, which is the NFVI layer, or it can also be implemented in a normal virtual machine. In a server virtualized environment, we have a VM, and there also these VNFs can be installed and deployed. A single VNF composed of multiple components deployed over multiple VMs or in an NFV in an infrastructure also is possible. So, the last layer, which is the management and orchestration layer, this is called NFV Management and Orchestration. This the VNFs, the virtual network functions alone, one single VNF separately is really not sufficient. What we have to do is we have to combine a set of VNFs and orchestrate them orchestrate among them and create a meaningful NFV, and that is what this particular layer does. Is this Mano orchestrates among all the VNFs whatever is required and comes up with the overall functionalities that is required by a certain environment. So, it is a collection of functional blocks, data repositories, reference points and interfaces for functional blocks to exchange information for the purpose of managing and orchestrating the NFVs and the NFVI and the VNF. So, VNFs are deployed in the infrastructure, which is the NFVI, and NFV Mano orchestrates these deployed functionalities and makes an overall meaning out of them. So, orchestration and lifecycle management of resources includes database to store the information and data models for deployment and properties of the functions. So, this is the overall picture of NFV in cloud services. If we look at the left hand side block, this is our CPU storage and bandwidth, this is the physical layer, and then we have the virtual machine layer. This is the virtualized on top of the hypervisor, this is the layer that is running. These are the virtual machines that are being used, and then we have the software framework, and on top of that we have the business applications and web services. If we equate this stack with our cloud stack, then to be able to implement IaaS, infrastructure as a service, we have to look at the virtual machines, and this is the layer we connect. And to be able to do PaaS, we have to give this layer, which are the system software and that the framework, the software framework that are there, and this is where our SaaS programs or softwares are installed. If we want to connect this to our NFV, then this is how it is connected. This NFVI spans the virtual machine and the physical infrastructure, and this is the physical infrastructure and the virtual, this is the NFVI infrastructure, and the VNFs are here. Each of these VNF will virtualize some network function, and putting them together we have the Mano, which will help them to be put together, connect together and make the useful or required mechanism. Now, NFV virtualizes it can virtualize all the network functions. In fact, today in cloud environment, we do not see any directly implementable environment for network. Everything is almost everybody is using some virtualization or other in a data center. But is it sufficient to have only NFV. This is a process of moving the services, those are functionalities. They have given, we can give the example of load balancing or firewalls or IPS, etc. And this is taken out of the dedicated hardware and put in a virtualized environment, but the NFV inherits the constraints of the, because that is not logic, that is physical. The basic architecture is still stuck in the components. Therefore, whatever the functional virtualization can do cannot be mapped to the physical world. So, constraints still remain the same. Therefore, just virtualizing the functionalities and making them run in a server is not sufficient. We need to go beyond this. And let us look at the issues for conventional network. It is difficult to configure. It is reconfigured if there is a fault or there is a change in the pattern, usage pattern or something. It is very difficult to reconfigure. It has to be reconfigured. So, everything has to be stopped, things have to be pulled down and again rebuilt. Very difficult process. Network operators need to configure each individual network device separately. So, to get rid of this requirement, the next mechanism that we are looking at is called the software defined network or SDN. So, what is SDN? SDN is the virtualization of the network components, devices as such as routers, switches. These are the physical devices which is virtualized using SDN and implemented through a server. So, it provides a centralized network control and ability to program the functionalities also. It adopts a flexible network policy. So, the policies will be now in SDN, the policies will be in the server also. Shape the traffic from centralized console without directly accessing the individual network devices. Coordination, automation and exception handling of a network is done using SDN, and this provides a better environment for our applications. So, what are the features? It is a programmable, obviously virtualized programmable environment. It is abstraction and dynamic control, automated and secured based on open standards, and it is vendor neutral. So, whatever is done for everything in a network, the telecom companies have their own products, and that is what they are going to use if it is a product. But when we take out the logic out of the physical machines and keep the logic in a server and run the logic in the server, then we have the benefit of being free from the vendor specific work. Once I design the logic outside the vendor specific network, then we can put it and we can manipulate the. So, packet moving decisions are taken out of. So, when we allow a packet to go in a network, then leave it to the routers to route the packet properly and in the correct direction. We have seen multiple times that it does not work. The packet is supposed to go to A, it can take the shortest route, it can take a very long route, it can take even a longer route and get dropped at some point where it faces congestion. So, there have been for many long time people have been trying to get rid of this dependence on the router, dependence on the point at that point in contact which has to decide at that point in time, and SDN perhaps gives that advantage of taking that decision away from the physical environment. So, here are the advantages are quite obvious, that it is simple, less error prone because we can correct our errors much easily. if we decide on a new policy, if we come up with a new routing algorithm, if we want to try out a different way of doing our work in networks, it is much simpler to implement it in a server environment. Control program can automatically react and centralized control logic. So, what about SDN and NFV? Do we need both? Can we use any one? So, this is a comparison of NFV and SDN, but what is a fact is that one NFV only virtualizes the functionalities, SDN virtualizes the network policies and the physical elements of the network elements. Together they make a great team and they can completely virtualize the overall. Although it is not required that SDN be NFV be implemented on top of SDN, but NFV is the functions which requires a physical an environment where it can be implemented. We can implement it on the actual physical network, or we can implement it via SDN, which is a virtualized physical network, and through that we can go to the. So, both solutions can be independently used, but together they implement a great solution. Now, to be able to achieve SDN, there are two methods that have to be used. One is the software vSwitch and the other is called the open flow protocol. The open vSwitch, which is a software switch, is that provides the switching stack for the components, the virtualized components. It can operate in the software based stack and it can operate in the control stack of the switching hardware. It supports multiple tunnels and thereby providing multi-tenancy. Each tunnel will be used by one tenant and they will be separate from each other. It is very flexible. Open flow similarly is a programming interface between switches and controllers. Based on the rules, it will act as a router, switch, firewall, etc. It has two functions. One is the data path, which is the switch, the data that has to be flown, and it has a routing decisions which can be moved between separate controllers. Open flow switch and a controller communicate via open flow protocol. So, the overall is called a network as a service. Let us look at what is a network as a service and what are the benefits. This is managed network solution delivered on demand as a service. It is a virtualized environment and it optimizes all the resources. So, we can implement VPN. We have already seen in our earlier module how to implement VPN. We can do a custom routing. We have multicast protocols and we have the bandwidth on demand and security. So, to continue with the NaaS benefits, it has the ability to deliver any new network. It is a flexible capacity controller and it improves the overall on demand networking provisioning. Deployment is very rapid using NaaS and therefore, reconfiguration of the physical diagram is data is not required. So, to conclude this module, we have looked at two major virtualization mechanism that works in networking. One is to virtualize the functions, which is the NFV, and the other is the software defined network, which virtualizes the physical environment. Both these contribute a lot to the cloud environment, because any data center, we need a lot of interaction in a data center, across data centers, across the different clouds, and this can easily be done when we can decouple our networking requirements from the physical networking devices and functionalities. And both SDN and NFV
are doing that. So, increased communication among data centers requires increased implementation of both NFV and SDN, and preferably in combination with each other. So, these are the references. Thank you.